Thank you for creating time to join this class again today. And so far, what we've covered in the last 4 days has been geared towards looking at the various technologies and philosophies around them that can be used to help any government or any institution that is desirous of achieving the SDGs do that. And the reason we saw why emerging technologies are critical to the achieving of the SDGs was that these emerging technologies provide us with a way to leverage our productivity in such a way that the economic production process is near zero marginal cost. And we saw examples of that. A good example being an artist who produces music today compared to the olden days. In the olden days, to reach an additional music fan, they would need to produce an additional CD or an additional cassette or the additional LP player. So that changed a bit when radio came, and for the musician to reach a wider audience, they would use radio and TV and so on and so forth. But that leverage has also been further advanced by use of modern internet technologies. The musician of today simply needs to upload his music videos and audio files online and do no further than marketing. There is no more additional effort in terms of getting his album to, or his music to additional fans. And the leverage that the internet provides is that the distribution mechanism, because I'll give you an example of a musician in Kenya. Once he releases a song and puts it on YouTube, the distribution mechanism of the internet is such a way that the service is available globally at nearly instantaneous times. And the musician therefore does not need to involve or engage in additional activity to meet the demand of his customers. And all this has been enabled by the existing technologies such as the internet and mobile communication and all that. We are now starting to slowly see the adoption of artificial intelligence, which is geared towards further improving this productivity. And if we are to start talking about artificial intelligence, I would not know even where to begin, because it's a very wide topic, all the way from the deep technical aspects of it to developmental aspects and even to political aspects, depending on who is discussing the topic. But in the bottom line, we have seen that, or we've even heard of talk that data is the new oil. I'm sure most of you have heard that saying that data is the new oil, and that data can be used to spur innovative change in as far as our world is concerned. And why is it called the new oil? It's because artificial intelligence is not really a technology as such, but artificial intelligence is, I would consider it a tool, yeah? The same way we had the horse, then the car, then the aeroplane. Those are tools that significantly improved transportation. Before the horse, man used to walk, and the farthest they would maybe cover would be maybe 50 kilometers. With the horse, that was increased to maybe 100 kilometers. But with the car, that was drastically increased. And you saw what the plane did. We can now go to any point in the world within a span of about 12 hours from anywhere. That is the significance of the use of tools to help man basically do things better or improve the quality of man. Now, we've had many tools that we've invented, all the way from Stone Age tools to robots today. But all these tools actually exist in the physical world. They help us do things in the physical world, while a lot of what we are doing currently is predominantly shifting to the online world. The question then comes in is, aren't there existing tools in the online world that can help us maybe leverage whatever we do online for higher productivity? Yes, there are, but none of them even come close to what artificial intelligence is capable of doing. And by that, I mean AI is a tool with extremely high leverage to significantly improve our productivity online. And we'll see those examples as we go on. And AI can also be considered as a resource, just like the way we consider RF spectrum as a resource for communication, or the way we would consider a physical telecommunication network as a resource to deliver services closer to the people. So AI can be looked at as a digital resource, not really as a technology per se, because AI is actually a result of the clever use of various technologies underlying it. There's no technology really called AI as such. And that's why even in the diagram here, it's just written new technologies, which now come together to be used by AI, which when combined with data can lead to significant innovative changes. And when you talk of innovative changes, we're not talking of small things like when you're typing in Yahoo, in Gmail, when you type sincerely, it auto-completes, and then you just hit the tab key. And then when you start typing Y to type yours, it auto-completes. That is a very basic use of AI, and we'll see that later. But it's still an innovative way of simplifying work. Let's look at a real case, significant application of AI. And this is a recent case which we've all seen when it comes to the fight against COVID. Let's watch this. Tell me if you don't.
Where is the vaccine for novel coronavirus? According to the World Health Where is the vaccine for novel coronavirus? According to the World Health Organization, it is still 12 to 18 months away. It's not a short time, but it's surprisingly fast, as it used to take 8 to 20 years for a new vaccine. So how will we achieve this breakthrough speed? AI plays a key role. Vaccine R&D has 3 points: massive data analysis, literature screening, and knowledge mapping. That's exactly the form of artificial intelligence. To better illustrate, let's first look at how vaccines work. Vaccines contain dead or weakened pathogens which can make the immune system produce antibodies, and they will remember how to fight the virus. The novel coronavirus is RNA wrapped in a coat of proteins, which are what our system mainly responds to. Last episode, we talked about how Chinese scientists use AI to get the full genetic sequence of novel coronavirus. Thanks to that, the process has been greatly accelerated. But the jump from gene to protein is still a big one. This is where AI steps in. Using big data and probability models, it helps researchers predict and select possible protein structures. AI is much faster and more accurate compared with human predictions. After obtaining these structures, we can design vaccines to make us produce an effective response without making people sick. As the pandemic continues around the globe, there is a strong chance that COVID-19 could be regular. If that's the case, a reliable vaccine may be the ultimate solution for the world. The good news is that 3 vaccines have been in clinical trials in China. What's more, Chinese scientists are working for international cooperation to unlock the cure for the pandemic. If you want to know more about the mind-blowing technology being used in the fight against the coronavirus, stay tuned and subscribe to our account. See you next time.
So that was an example of how coronavirus vaccine research is being accelerated by AI. And that video said that in traditional vaccine research, it takes about 8 to 20 years, depending on the amount of work that needs to be done to come up with a vaccine. But we've all heard of the UN, WHO, and other governments promising a vaccine within 18 months. And the reason why they are confident they can do that within 18 months is because artificial intelligence has accelerated the pace at which research can be done to come up with new vaccines. And when we also talk of innovative change, we do not just mean at a very high level in terms of research in vaccines and all that. It could be just for general daily use. The other day, one of my neighbors had a shampoo bottle, which she had acquired from somewhere. And she was really wondering whether it has what she needed, because it was all in Chinese. So actually, I'm the one who took these photos that you're seeing. We took the, I took my phone, opened up Google Translate, then aimed the bottle text using Google Translate. And this is the picture I took of the bottle, and this is the translation that Google Translate did in real time. As you can see there, there's a word continue translation, because as you move Google Translate across the text, it automatically translates whatever you are seeing into a language of your choice. It could even do it into Kiswahili. So you see, with such technologies, the application to daily lives are many. I have also used the Google Translate, which is a very good example of how AI is used to simply open, there's a software called Google Lens. You simply open Google Lens in your Android phone. And if, for example, you find a flower on the road or in the garden, and you're wondering what type of flower is this? Traditionally, you would need somebody who already knows what that flower is to tell you this is a rose flower, or maybe this is a hibiscus flower. With Google Lens, all you need to do is point Google Lens to the flower and snap a photo, and it will tell you this is maybe a rose flower, or this is a hibiscus flower, or this is a certain type of plant. In many cases, the way I've used the lens is some of the fruits or plants that I know in my mother tongue or in Swahili, and I'm wondering what is the name of this fruit actually in English. You take a photo, it tells you this is called a certain fruit. So the power of AI transcends just high-powered research and big data crunching. It also involves simplifying our lives, and there are many examples that AI can be applied. At the moment, the biggest application of AI is online in terms of the organizations that provide internet services or cloud services, the likes of Google, on Gmail, on YouTube, Microsoft, and all those heavily deploy AI in their products. Yeah. So if you are using Gmail, or if you're using YouTube, for example, and the suggestions that you get of the next video, or the video suggestions that you get, are based on an AI algorithm. That is just one example. When you do search on Google search, all that is also AI. But this AI has been mostly used to improve the efficiency of these organizations. And the reason why tech firms have overtaken the traditional players in as far as being the largest companies are concerned is because tech firms have been able to massively leverage AI. 30 years ago, it was the likes of GE, General Electric, it was the likes of Siemens, it was the likes of Coca-Cola that were ruling the top tier in terms of large companies. These days, if you look at the top large companies, the top 10, about 6 to 8 of them are technology companies. And all of them, the common thing with them is that they've been able to leverage artificial intelligence. But then that is too much talk. What is really artificial intelligence in as far as defining it is concerned? Artificial intelligence can be essentially defined as the theory and development of computer systems. And this theory and development is essentially to enable these systems perform tasks or do things that under ordinary circumstances would need a human being with the considerable intelligence to perform. And some of these tasks include like speech recognition. To be able to recognize speech, you need human intelligence. Visual perception, to be able to tell this is a cat and this is a dog and this is a car, or this is a car and it's a Toyota and this is a car and it's a Mercedes-Benz. Such kind of visual perception. And other things to do with the decision making, making decision based on data, making decision based on inference, and so on and so forth. And also translation between languages, which is a good example that we saw in the past slide, that we are able to translate from one language to the other easily using artificial intelligence and all that. Another definition, which is a definition by Ray Kurzweil. And Ray is the director of engineering at Google. You should read about him. He's a man with a very distinguished career as far as artificial intelligence and machine learning is concerned. If there was ever to be a Hall of Fame of AI pioneers, then Ray would be one of the first inductees into the Hall of Fame. So Ray calls AI as the art of creating machines that perform functions that require intelligence when performed by people. So any function that a person performs and requires intelligence, then that is artificial intelligence. That of course means that there are some functions that we do as humans that do not necessarily require intelligence. So that wouldn't fall under AI. Now, I've been talking about the significance of AI, but how significant is it? In our first slide, in our first session, I'd mentioned about Andrew Ng. Andrew Ng is also pioneering researcher in AI. He's the founder of Google Brain. Google Brain is responsible for now what we have as the standard model of AI used in the world. And also former chief scientist at Baidu. And what he says is that the same way electricity was significant 100 years ago, and the way it transformed the world, AI will do the same, yeah? And AI will influence each and every industry, the same way electricity has influenced each and every industry. Electricity is not just used in manufacturing, it is used across all industries. There is no industry or facet of society that does not use electricity. But there are facets of society and industries that maybe do not use some of the technologies that exist today, like robots. But when it comes to AI, there is no industry that will not be influenced or transformed by AI, yeah? And the reason is because AI can significantly increase productivity with nearly zero marginal cost, because what you're doing with AI is that you take our ability to intelligently interpret things as humans, which is innate or inherent in us, and you move that ability into the digital space. That is essentially what AI is doing. That our ability to interpret and make decisions on the physical world around us is still lacking, significantly lacking on the digital space where we do most of our activities. So if we can transfer that ability to the digital space, then we will significantly improve how we operate and do things. And AI has many uses, but there are several types of AI which are important for us to have a clearer understanding of what AI is and what AI is not. And this is because there has been a lot of talk and a lot of hype around AI. If you go online, I can assure you that 80% of what you read about artificial intelligence is hype. There's a lot of hype online about what AI can do, and truly so, but what has actually been achieved away from the hype is significant, but it's not as major as it is being made to be. Yeah, that's what we need to know. And the reason for that is because we are still at the initial stages of AI. We are still at what is known as narrow AI. And that is where we are currently, and we've made significant improvements in that. And narrow AI is also known as weak AI. And I've said this is what we use today, and it's used for efficiently carrying out single tasks. For example, when you talk to Alexa, when you say, hey Alexa, tell me about the weather, and Alexa responds. Or when you open your weather app and it's able to know you're in Nairobi and this is the weather for Nairobi for the next 10 hours and all that, and it displays to you, and so on and so forth. So the current AI that we use, even the one that we are using on websites to, for example, suggest to you the next video based on your previous watch history, maybe suggest to you the next song based on your previous listening history, and so on and so forth. Or even organize your search results in such a way that it is formatted to your personality based on your activity online, yeah? So that is narrow AI, and we are still there. And the next phase, of course, is known as artificial general intelligence, is also known as strong AI. Some people call it deep AI, but it might create confusion there with the word deep learning. But in this type of AI, it's where the machine with this type of intelligence somehow mimics how humans behave, and it can apply this ability to solve problems. Yeah, and we will see subdivisions of this later as we go on. And then the third one is actually artificial superintelligence. But before we get there, what we need to know about artificial general intelligence is that it is now that we are also starting to make advances towards the development of artificial general intelligence. And the difference between artificial general intelligence and narrow AI is that with artificial general intelligence, the system is able to use data or knowledge it has or experiences from the past to make a decision about the future. For example, if a car is driving down the road, when you talk of driverless cars, driverless cars are one of the first initial steps that are taking us from narrow AI to artificial general intelligence. Because unlike narrow AI system, like maybe a virtual, let's say a system that is playing chess. A system that is playing chess will simply look at the chessboard, do its calculations, and decide the next move. It does not need to know what was previously done or how the game was played previously. But in a self-driving car, that car needs to remember a little bit of history for it to make the next decision. Yeah. For example, it needs to know that I am here, I stopped here 3 seconds ago because the traffic light was red. And it also knows that last time I crossed this road, maybe the green light took this number of seconds. So all that information is able to be used by the vehicle, and the vehicle is able to make decisions just like a human being would. And that's why we say it mimics human intelligence. And when it comes to artificial superintelligence, this is actually intelligence that greatly exceeds our human capability in as far as intelligence is concerned, which is the cognitive performance. And the way we will arrive at artificial superintelligence is if we will be able to create an artificial general intelligence that knows how to train itself to learn more and become better. So if we create an artificial general intelligence system that can train itself and learn things, new things, the same way a human being learns things. You touch fire, you learn next time I should not touch fire because fire can hurt you. You eat rotten food and you get a stomachache, you learn that eating rotten food can give me a stomachache. That is learning. So artificial general intelligence, when it reaches a point where it can self-train and self-improve, and self-improve doesn't just mean learning new things. It also means itself looking at its algorithms and improving those learning algorithms in addition to it learning new things. So that can happen, and there are predictions. Somebody like Ray Kurzweil says by around 2040, 2050, we will reach artificial general intelligence that is capable of self-improvement. And there's a danger there that if artificial intelligence is able to self-improve, then what will it teach itself? Yeah, because if it becomes so intelligent, then of course, the first thing it will ask itself is, what do I need to do to stop people from shutting me down? See where we're going at that? Because that presents a danger in itself, because if this system is a runaway artificial intelligence improving system and goes on to create an artificial superintelligence that might be uncontrollable, no one knows the effects of that, then we'll be in danger. And that is why when you talk of artificial general intelligence regulation and best practices, it is aimed at addressing such possibilities that, yes, today we want to advance AI, but how do we do it in such a way that we do not end up creating a system that we are unable to control? How do we create a system in such a way that its use would be of benefit to us? Now, today, if we were to use if it was possible to create artificial superintelligence today and use all the data that is on the internet to train it about who we are as man and what we do and what we like and what we don't like. Number one, the internet is very biased. There is a lot of inequality on the internet today, yeah? So it will learn many things that are ideally biases that we've propagated online. Today, if you go to Google and search bad office men's hairstyle, yeah, bad hairstyle office, majority of the results that will show those photos will be black people with afros and dreadlocks and all that. Bad office hairstyle. If you type good office hairstyle, you end up seeing very many whites. So what is that telling you? If artificial intelligence was to learn about what is a good hairstyle and what is a bad hairstyle, guess what it will learn? That blacks always have bad hairstyles because somebody sat down and decided this is bad, this is good. So there is need for us to put in place measures that will stop that from happening. And that can be stopped by ensuring that the regulatory framework for AI is in such a way that as AI advances from narrow AI to AGI to ASI, which is artificial superintelligence, we train it with data in such a way that the outcome of whatever we are making to become an artificial superintelligence is something that will benefit us. It's not something that will be a monster, that will greatly amplify our biases on offline. And I gave an example the other day of an AI system that was being used in the US, in one of the counties, to mete out sentences. And it was found that for the same crime, blacks were getting harsher sentences than whites. And it's because the system, the data that was used to train that system was that way. That could be the reality on the ground, that maybe there are many blacks in prison, but that does not mean that for the same crime, a black should be punished more severely than a white. That is not what AI should do, yeah? Do we have any question up to there before we proceed? So we can proceed. Now, the question that usually comes out is, why is there a sudden interest in artificial intelligence in the last 5 years or so? And yet, artificial intelligence has been known to exist for a long time, and the techniques have been known to exist for a long time. For example, machine learning is as old as some of the techniques that we are using today, such as neural networks in machine learning, were invented in 1958, 57, 58 there. But they've been there. But how come we've never been able to use them? Now, the first one is because there are three things that have happened that have accelerated the use and application of AI. And the first one, as I've said, is that machine learning algorithms have drastically improved. There have been new methods and new ways of training systems to learn. And there are many machine learning methods, but the most useful one today, and the one that is commonly used to train AI, is one which is known as deep learning. So deep learning is one of the methods of machine learning. There are other methods that can be used to train systems. Yeah, and we will see the classifications of the machine learning methods before. Later. The second thing is that there has been drastic improvement in computing, and that computing has become much cheaper and more powerful. And this is enabled by the hyperscale cloud computing. If I needed to train a machine learning model in my house, for example, or in my office, I would need a lot of computing power. I would need a lot of storage, and I would need extensive knowledge in as far as training these systems are concerned. I need to be very deeply knowledgeable when it comes to machine learning. But hyperscale cloud computing has simplified that, and I'll show you later. We are now able to, like now, if I decide, let me create a machine learning model that can do, let's look for a local example here. I want to train a machine learning model that can predict the performance of children based on the type of food they eat. Yeah, maybe I'm doing a research to find out does the type of food impact the intelligence of kids in schools, and I need to create a model to train a system that can be able to predict that based on the foods I enter. So I might enter 20 foods and it can tell me these ones can lead to this kind of outcome. So for me to do that, all I need to do now is log into one of the hyperscale cloud computing platforms, let's say Microsoft Azure, or go to Amazon Web Services, AWS, the two of them that we logged in the other time. And I do not even need to understand machine learning deeply. These cloud services already have pre-modeled systems, and it's now easier to train an AI algorithm or an AI system by simply dragging and dropping, creating an algorithm online. Yeah, so it is very easy. You do not need the deep knowledge to be able to train a system on machine learning. And there are many tools that these providers are giving to end users. Yeah. The ability to run these algorithms fast and efficiently is one thing. The ability to store data and crunch this data very fast is also another thing. And that is the third thing which has led to the improvement in artificial intelligence. That is big data analytics and methods. This has also seen a significant improvement thanks to the massive amounts of storage space that are available on the cloud. You can dump whatever amount of data you want on the cloud today and apply machine learning algorithms on it and get an AI system out of it that can learn. Yeah. One of the projects that would be very significant is the government, as one of its key objectives in ICT, for example, might decide that one of our mandates is to bring people online, the unconnected online, other than just using universal service fund to take services to them. We can also maybe use the USF to work towards training machine learning systems online that can speak the local dialects. Yes, Google will do Kiswahili, Google might do Zulu, Google might do Somali, but Google might not do Ogiek or Kuria. And those people will be left outside, as others are proceeding. Yeah, the digital divide will be wider for those people, especially when artificial intelligence comes in. So the government might decide that we are going to put policies in place to ensure that our entire population is online, And the way to use AI is to train machine learning models on the local dialects. And that is doable. There are so many vernacular stations here. All that is data that can be used to train machine learning systems. All that. If you feed, let's say, which Kikuyu stations are the most, the most. Let's say if you feed 5 Kikuyu station output continuously for 6 months into a machine learning system, I assure you that machine can speak Kikuyu. But somebody needs to sit down and do it. Investments need to be made to ensure that even as the world progresses, some people are not left behind. Because Google might do Kiswahili because their statistics show there are over maybe 200 million Swahili speakers and all that. So it's attractive for them. But they might not really focus on the other smaller languages. So that would be something that the government can think of, that the same way we were focused on taking public telephone booth to every shopping center in the earlier days, then our focus shifted to everyone having a mobile handset in their hands to at least make a phone call. Then our focus shifted to not only having a mobile phone on their hands to make a phone call, but also have access to data. Then our focus shifted from not only should they have access to data, they should be able to use the internet in a meaningful way. That is now digital inclusion. So we focused a lot on bridging the digital divide. We have now slowly started to focus on digital inclusion. And I can assure you, AI is the surest way of accelerating digital inclusion. So that is why AI is attracting a lot of attention. Now, we talked about machine learning and training of AI. What we mean is that when we talk of artificial intelligence, we mean a system, a basic system that is designed, and then it is taught to learn and make decisions based on what it is learning. Yeah. And there are 3 types of learning. The first one is called supervised learning. In this case, there's somebody who is seated there and guiding the AI system by providing sample inputs along with the desired input. A good example is if I'm doing supervised learning on an AI, if an AI is being trained using supervised learning, I can feed a photo of maybe a street. And then I select the traffic light and say that is traffic light. I select the car and say car viewed from the back. I select another car viewed from the front. I select a garbage bin next to the road and say that is a garbage bin. I select a fire hydrant, that is a fire hydrant. I select a fire engine that is in the picture, say that is a fire engine. Then put another picture. I say this is a one-way street because the central lane markings are white. This is a two-way street because the lane markings in the center are yellow. So that way I'm training that system. And that is what is happening currently when it comes to training driverless cars. There's a company in Kenya called Samasos. Who has heard of Samasos? Anyone? So Samasos employs a lot of youngsters from impoverished areas, the slums and all that, who at least have a high school education and can use a computer. And what these kids do, okay, they're not kids as such, but they are of employable age. But what they do is that for the entire day, they sit down and train AI systems for driverless cars. So Samasos would receive a lot of data, maybe from General Motors in the US, and say, this is the data we want you guys to train our system on. So these youngsters will log into the system and maybe open a picture and do exactly what I've said. This is a fire hydrant. That is a stop sign. That is a traffic light with the green light on, meaning you should go. That is a fire engine that is on the wrong side of the road. It can use the wrong side of the road because it's a fire engine, and so on and so forth. So these kids train these systems on a daily basis. So somebody might sit down and maybe label close to 200 pictures a day of different parts of America, different parts of the world. And with all that data, they are training a system for driverless cars. They can receive information maybe from BMW or Audi, and they're able to train these systems. That is called supervised learning. So this system will only learn if you tell it this is the input and this is the output. And essentially what these kids are doing is what is known as labeling. They are labeling the data that is being used to train this system so that this system can know. Yeah. The other method is called reinforcement learning. And in this method, the AI algorithm learns through trial and error and gets rewarded for the desired performance. Yeah. A good example is when you are training an AI system for gaming. You really can't train it in any other way other than by use of reinforcement learning, where if you are using the system and, for example, in the game somebody scores or wins a point, then you mark that as a good outcome. Then the game knows, oh, okay, so my aim is either to make scoring very difficult or very easy, depending on how you programmed it. So the system keeps on learning and it keeps on getting better as time goes on. The third method is known as predictive learning or unsupervised learning. And here, this system is not given any labels like we saw in supervised learning for its input. And it's left to figure out and structure its own inference of what that means. Yeah. And this is the method that is commonly used. Deep learning is one of the methods of unsupervised learning. So in supervised learning, there are several methods. In reinforcement learning, there are several methods. In unsupervised learning, there are several methods, but the most preferable one is deep learning. Now, deep learning, as we mentioned, uses neural networks. Now, what are neural networks? We'll see that later, but essentially, a neural network is an attempt to mimic how neurons in the brain are structured and how they store information and understand things. Yeah. A good example of how neural networks would learn is by use of, let's say, a picture of a cat. If it's a picture of a cat, then what makes the AI system say this is a cat and this is a lion? Yeah, how does it differentiate between a cat and a lion? It's by use of neural networks, because there is the first abstraction layer, just the way a human being thinks. There is a big animal and a small animal. It starts there. Of course, the big animal will be the lion and the small animal will be the cat. And it says, both animals have fur. Then it goes into specifics to the point that the characteristics of the differences between a cat and a lion are in each layer of the neural network. Yeah. The same way, if you saw something huge in the middle of Nairobi, your mind wouldn't immediately click, is that an elephant? Because you're in the middle of the city. But if you're in the middle of the jungle, you might think the first thing that might come to your mind is this is an elephant. It is because based on how your neurons have arranged themselves at that particular time, the possibility of seeing an elephant in Moy Avenue is significantly low. But the possibility of seeing an elephant in the forest is significantly higher, the chances of seeing it. So each step of a neural network increases or decreases the possibility of something or a parameter being true or false. So as we move on from the first layer where we say these are animals, because that would be the first layer, that both of these are living things. The second layer would be one is big, one is smaller. The third layer would be maybe one is brown, one is white. Or maybe one has protruding claws, the other, the claws are hidden. So you go deeper all the way to the point where if you have several layers of decision-making and probabilities, then you become more accurate. If you have fewer layers, then you are less accurate. If you have one layer, in the example I've used, you might say, this is a living being. That's it, the layer is over, and the analysis is over. If you have two more layers, you might say, this is a living being, this is a living creature, and it's an animal and not a plant. Another layer might say, this is a living creature of maybe the cat family or the primate family. So the more the layers, the better the accuracy and the decision that can be made, and the better the learning. And that is why it's called deep learning. Now, what was found out in recent years is all the existing machine learning algorithms had their limit. Up to a certain point, the performance of that algorithm did not improve significantly, despite the amount of data you threw at it. So the more data you fed into the system, there was no significant improvement in performance. And by performance, I mean in terms of it learning, whatever it is learning. Then it meant that there was a limit in terms of how much data can be used by a machine learning algorithm. But then, while they were trying to solve that problem, some people revisited the old method of using neural networks, which was invented in the 50s. And when they applied it to try and train a system, they made a discovery that if you use a small neural network, the performance improves. If you continue adding the layers, which is what is known as a medium neural network, maybe has several layers, then the performance also improves. However, as you continue increasing it, the performance tends to get exponential, the bigger the neural network is. But then the challenge was that for you to train a big neural network, you needed a lot of data, you needed a lot of processing capacity and storage and all that. And this is only possible now. So the reason why neural networks are preferred method of training AI is because they are the most efficient in as far as utilizing the amount of data we have. Remember, I mentioned that 90% of the data we have today was generated in the last 2 years. So that is a lot of data that we can use to train big neural networks for machine learning. Now, when you talk about neural network, the first one here shows a neural network where there's input, then one layer, then the output, yeah? But in deep learning, as I've explained, there are several layers and it's more accurate. In this scenario, this input might get data about a living thing or trying to analyze something, and then the output here might be, that's an animal or a plant. That is the output here, yeah? But in deep learning, if you add more layers, you become more accurate. So you might have a deep learning system that can differentiate cats and dogs. It might have maybe 10 layers. But if you add it to 15 layers, not only will it be able to differentiate cats and dogs, it can even tell you the species. This is a Chihuahua, or this is Siamese cat. Yeah. Not only can it be able to do that, if the layers are deep enough, it will be capable of telling you this is a kitten. It's no longer telling you this is just a cat. It will tell you this is a kitten. Yeah. And if the layers are deep enough, it can tell you this is a cat and it's walking, or this is a cat that is lying down. Are you getting the point? So to enable artificial intelligence systems learn, the more the layers in the neural network, the better that system learns. But the problem is that the more the layers, the more the complex the algorithm or the system, and the more the power consumed in terms of computing power to train the system, or even the more the time. So the way in which deep learning has become popular is because deep learning, you can either speed it up by having a very deep neural network, or you can speed it up by having a lot of data. So those two, either a very deep neural network or a lot of data. So in a situation where you have a lot of data about what you want to train the system on, then you might not need a very deep neural network. But in instances where you do not have enough data, you might need a very deep neural network. Let me give you an example. On the internet right now, there are so many photos of cats, all types of cats and dogs, very many photos. So to train a system to identify the different species of cats would be very easy, because nearly every species of cat has a photo on the internet. Yeah. But if that was not the case, it would mean that the little information that we have about cats, maybe there might be only one picture of a Siamese cat on the internet. That is very little information. We need to go deeper in designing a machine learning algorithm so that this system is able to differentiate the different species. And that also takes time and consumes a lot of power. So in short, that is the neural network relationship to machine learning. And we've said that deep learning is the use of deep neural networks for machine learning. So deep learning is a method of machine learning that is very popular because it is very good at what it does. And the reason why it is very good at what it does is because it uses neural networks. Because there's usually a lot of confusion between what is a machine learning, what is deep learning, what is a neural network. That is the relationship. That deep learning is a machine learning method that uses neural networks to train the algorithm. So majority of the existing artificial intelligence training systems are actually based on neural networks, majority of them. So you have input, then several layers of inference until the result comes out. So if you input here a picture of a cat in this deep network, it might come out there and tell you that is this species of cat. Yeah. But in a small neural network like this, if you input a picture of a cat, here it might tell you that is an animal. Yeah. So that is the difference between a neural network and a deep neural network for deep learning. Now, I want us to touch on types of AI, then we can take a brief break. And there are basically 4 types of AI, not to be confused with the types of trainings, the ones that we just covered. These are the types of AI. And this also should not be confused with what we had covered initially when we were talking of narrow AI or artificial general intelligence. Now, The first type of AI are what are known as reactive machines. And these are machines that perceive the world and act on what they see or what they perceive. A good example is AlphaGo and Deep Blue. Deep Blue is owned by IBM, AlphaGo by Google. AlphaGo used to be a company on its own, an AI research company, but was bought by Google. So Deep Blue and AlphaGo were able to beat the world top chess players in chess and also in a traditional Japanese game called Go. And what had happened is that these researchers, for example, in AlphaGo, they designed, initially it was called AlphaZero, which played chess, and then they converted it to AlphaGo, which now plays the Go game. So they designed a machine learning algorithm that 18 hours before the game started, some years ago, the system had just been designed and it did not know a single chess move 18 hours before the game. And they started training the model 18 hours before the game. And when the game was played, the AI system bet the world's best chess player, hands down, severally, not just once. The same thing for AlphaGo. 18 hours before, it was trained to learn how to play Go. And Go is even much harder than chess, much harder than chess. And the system also bets the world's top Go player, some Taiwanese guy, severally. So a reactive machine simply looks at what is in front of me and makes a decision and says, okay, based on what I know about moves and what I know about the king and the pawn and the whatever other characters are on the chessboard, this is what I need to do. And these are the moves I have, yeah? And thing you need to know is that it's not because these systems are powerful. AlphaGo is a system that was trained using unsupervised learning. And it had like several million moves to know that I can play chess this way. I think they're about 50 million. There existed previously systems that had even more number of moves, but those systems were not trained using unsupervised learning. They were trained using rule-based artificial intelligence training. Rule-based means this system has all the possible moves in its memory stored. While unsupervised learning means this system knows what moves mean what, and what moves should be made over what priority of what move is of more priority than the other, and makes that move, yeah? Or which move will help it move closer towards the goal of winning the game, yeah? After that, we have limited memory, and I give an example of self-driving cars. They can recall the recent past, yeah, and take action. For example, if the car is running out of charge, it's able to know that this was because of traveling this distance, or it's able to know 5 minutes ago or 3 seconds ago, I crossed a red light. So it means the next traffic stop is going to be red or green. So it can make a decision early in advance based on information it already has from previous actions. The third type of AI is what is known as theory of mind. This is a term in psychology. And whereas the first one, which was reactive machines, this system simply took action based on what they see. Unlimited memory can recall a little bit of the past. In theory of mind, these systems not only remember the past and can take actions reactively, but they also know about other entities in their surrounding, yeah? This is moving us closer to general intelligence, as you can see. Where are we currently? We are somewhere are moving away from limited memory towards theory of mind by creating systems that, or entities that not only are able to represent things out there in the world, but they have a representation of other entities around. And the fourth item or type of AI is called self-aware. And these are systems that can form representations about themselves. They know I am a system designed to do this, but we are not yet there, as we've seen, but we will get there. Now, why do we have all these different types of AI? Is because when you classify them this way, it is easy to see, for example, in your case, what would be of immediate focus in as far as making sure that all these systems are put into use in a good or ethical way, or are applied to achieve some of the key objectives that we need to meet, either as a country or, for example, the SDGs. So we play one video, which will talk about the golden age of AI. And then after this video, we'll take a brief break, and then we can come back later.
So on big ideas, artificial intelligence is something that I think has captured the imagination of Washington and probably the rest of the country and world. What is Amazon's approach to artificial intelligence?
Well, first of all, this is artificial intelligence, machine learning, artificial intelligence. It is a renaissance. It is a golden age. We are now solving problems with machine learning and artificial intelligence that were, kind of in the realm of science fiction for the last several decades. And natural language understanding, machine vision problems. It really is an amazing renaissance. And for decades, AI researchers kind of struggled and made very, very slow progress. And over the last 10 years, it looks like one of those S curves. You're just making a lot of progress very rapidly over the last 10 years. Machine learning and AI is a horizontal enabling layer. It will empower and improve every business, every government organization, every philanthropy, basically there's no institution in the world that cannot be improved with machine learning. So at Amazon, some of the things we're doing are super obvious. So they're kind of superficially obvious, and they're interesting and they're cool, and you should pay attention to them. I'm thinking about things like Alexa and Echo, our voice assistant. Thinking about our autonomous prime air delivery drones. Those things use a tremendous amount of machine learning, machine vision systems, natural language understanding, and a bunch of other techniques. And those, but those are kind of the showy ones. And I would say a lot of the value that we're getting from machine learning is actually happening, kind of beneath the surface. And it is things like improved search results, improved product recommendations for customers, improved forecasting for inventory management, and literally hundreds of other things beneath the surface. And then I'd say the most exciting thing that I think we're working on in machine learning is that we are determined to, through Amazon Web Services, where we have all these customers who are corporations and software developers, to make these advanced techniques accessible to every organization, even if they don't have kind of the current class of expertise that's required. Right now, deploying these techniques for your particular institution's problems is difficult. It takes a lot of expertise. And so you have to go compete for the very best PhDs in machine learning and get them. And it's difficult for a lot of organizations to win those competitions. And so we're in a great position because of the success of Amazon Web Services to be able to put energy into making those techniques easy and accessible. And so we're determined to do that. I think we can build a great business doing that for ourselves, and it would be incredibly enabling for organizations that want to use these sophisticated technologies to improve their own organizations.
So that was Jeff Bezos, the CEO of Amazon. And he's basically talking about the potential of AI in improving how we live and do things. And as is mentioned there, it's only in the last 10 years or so that we've seen an acceleration of AI use and application. And that is simply because of what I'd mentioned, that we've had drastic improvements in computing capabilities, and our storage capabilities has also improved, and our algorithms have improved significantly. So that is why now AI is attracting a lot of attention. And he's also reiterated what Andrew Ng said, that AI has the potential to change every aspect of our lives, just the same way electricity did. So let us take a break. And before we do that, I invite questions so that we can answer them, or any clarification that are needed. Any question? Okay, let's take a break then. We should be back now 11:35, we should be back. So I believe we should be back now. So let's continue, if that's okay. Or if there are any questions that arose during the break, you can raise them so that we answer, or any clarification. So as we come back to the topic, the other thing I needed us to discuss is we've talked a lot about artificial intelligence being enabled by the copious amounts of data that we have around the world. Then the question comes in is, how does this data come into play in making artificial intelligence work the way it's working today? And this has been enabled by the use of data science, which is a science that is used to interpret, organize, manipulate data for the purposes of either training AI systems or gaining insights from those systems. So by use of data science, we can extract insights from data and use these insights to train the AI systems. And of course, there is a technical aspect to it in terms of the tools and the methods and the platforms. So when you look at the tools, we are looking at things like programming languages. The most popular programming language today, or scripting language today for data science and machine learning, is Python. Some years ago, it used to be a language called R language, but Python is taking the lead. And anyone today who wants to do machine learning, it is not necessary for you to know Python or any of these languages, but it will significantly improve the complexity of the systems that you can design or the algorithms that you can design if you know Python. And that is why it is recommended that people who are interested in machine learning and data science should at least at the very minimum know Python. And Python is gaining popularity also because it's also being supported by nearly all the cloud players. I don't mean, I'm not saying that all these are not supported by the other players. There's a lot that is available online. Like if you go to any AI or machine learning platform on the cloud, you have the choice of either using Python or R language or using TensorFlow or Keras, whatever you're comfortable with, or whatever is suitable for that particular need that you're doing, yeah? For example, if you're doing voice, designing for voice, in this case, maybe a system like Dialogflow would be better. It's not listed here, but Dialogflow would be better if, for example, you're designing voice on Google. So it depends on the use, but in terms of popularity, that is the table as far as tools are concerned. Then there's also the aspect of the methods in terms of the methods that are being used by the various providers. Who leads in as far as the application and use of AI is concerned? Yeah. This is a Magic Quadrant from Gartner for February 2020, which shows who are the leaders when it comes to machine learning and AI methods. Yeah, and you see at the top there we have Amazon Web Services, we have Microsoft, we have Google, we have IBM at the leaders quadrant. There are no challengers to those guys as yet, but very close will be Salesforce. And we also have organizations that would be termed as visionaries. There's a company called H2O.ai, which is very popular with the people who do AI. It's little known because it's a niche market. It's not like Google or Microsoft. These are very niche market, but H2O.ai are well capable of designing very complex systems. Now, what you need to know is that this is in terms of their capabilities, but it does not mean that whatever you want to do, just because AWS is at the top there, then that is what you need to go for. You might have a requirement that might be met by another service. So it's up to you to decide. And then when it comes to platform, it's also very similar. But as you can see there, when it comes to leaders, Google has a very large platform. But in as far as infrastructure maturity is concerned, Amazon leads. So strategic commitment to AI, as in what are they doing now to invest in AI for the future, and how big is AI in their strategic goals? Google leads, followed by Microsoft, followed by Amazon. But in terms of how mature their infrastructure is to support AI, then Amazon leads, followed by Microsoft. No, sorry, IBM leads, followed by Amazon, followed by Microsoft, followed by Google. So if today a large organization, like for example, a bank in Kenya, let's pick the largest bank in Kenya by customer numbers. And they decide we want to employ AI to our business operations. So they will most likely, based on this graph, go for IBM. And then they might decide maybe other services that are not very strategic to us can go to Microsoft or Google. It's up to them. But the table clearly shows that there are those who have advantages over others when it comes to either infrastructure or their strategic commitment. Strategic commitment doesn't really mean much if you want to achieve whatever you want to achieve now. But in terms of choosing a partner to work with in the long term, if an organization today wanted to choose a partner that they can work with in the long term, they would either go for Google or Microsoft. But if they want somebody who is already there and mature enough to do AI for them and realize the benefits, then IBM would be the choice. Now, IBM is not really popular when it comes to cloud or AI, is because they are niche market again. They do not have like public cloud services as popular as these other guys. They have public cloud services by the but they are not as popular. So this table basically shows the maturity for each and every big player. You have Salesforce there, which has done quite a considerable job in creating one of the first fully cloud-based ERP system. Yeah, and then it's followed by SAP. I'm sure most of you have heard of SAP in commercial environments. So those are the leaders in as far as infrastructure maturity is concerned. Now, worth noting is that it is possible to use SAP in as far as what they can offer is concerned, but still run that on, let's say, the Amazon cloud. It is possible, or the Google cloud, because maybe you're after the infrastructure maturity of one of these players. So you might have your SAP running on IBM. And when I talk SAP, I mean the SAP ERP system itself. So you can have a SAP developed system or even a SAP AI system that is running on a different platform. And we saw how that is possible previously, using things to do with containers and all that. It's possible. Any question up to there? Today you are very quiet. No one is asking any question. Or either mnaelewa ama umepotea.
We are following.
You're following, eh? Okay. Now, when you look at all those providers that we mentioned there, as I've mentioned, they have different strengths. So if you're looking for an organization that will be very good at crunching and understanding your numbers, then IBM is a place to go. If you're looking for an organization that will simplify artificial intelligence, then Amazon Web Services would be the place to go. If you're looking for somebody who will be able to open up their systems and train you and give you knowledge and skills and enable you comfortably do AI, then Microsoft Azure would be the place to go. If you're on the other hand, you're looking for power in terms of speed of processing of AI data. So if for example, you are designing an extremely complex large system that needs a lot of, maybe with very many neural network deep learning levels, you might end up choosing a provider who will provide you the speed that is required. And what Google even recently did is they released a processor which is specifically designed for TensorFlow. TensorFlow, as we saw, is one of the methods in which you can use to program for machine learning. And Google is also at the forefront of offering specialized computing capacity for machine learning. And specialized computing capacity in both Google, Microsoft, and Amazon is run by use of GPUs and not CPUs. And the main difference, so the TensorFlow processor is basically a modified form of GPU. GPU is basically a graphics processing unit. It's the same chip that is in graphical processors or in graphic cards in computers. So on your laptop, the chip that is processing all that information you are seeing on the screen is different from the chip that is actually running the computer. And the chip that is doing the display or the graphics is known as a graphics processing unit, which is different from the central processing unit. So the GPU, by design, is designed to do one thing only, which is to display graphics. And the same method or the same design or the same approach it uses to display graphics from a mathematical point of view, because when you look at a chip, what it's doing, it's basically doing computations. So the same computations that are used in machine learning, incidentally, are the same computations that are used in graphic processing. And the GPU is much cheaper. Remember, the CPU is designed to do very many things. It can play music, it can play whatever it can play, even process information and all that. So it's not a specialized device. And therefore, if you have a CPU doing machine learning, you're wasting a lot of space and capacity, and it will be expensive because the price of a GPU and a GPU is much cheaper because it is a chip that is doing only one thing, while the CPU is designed to do very many things. So when they found out that the GPU is actually very good at machine learning, GPU started being adopted for machine learning. And if you look at the stock price for an organization like NVIDIA makes graphics cards. The stock price for NVIDIA has been skyrocketing in the last few years, because all of a sudden, the GPUs that they were making for graphic processors are being repurposed for machine learning. And as machine learning grew and artificial intelligence grew, the demand for GPUs became very high. So today you can go to, let's say, Amazon or Google, and when you're buying cloud services from there, decide, I'm not going to buy just a normal server, like the one we did the other time. I'm going to buy GPU processing capacity. So you might decide, I need 5 GPUs. And the other thing you need to realize is a GPU has so many cores inside. See the way your CPU there is written Core i3, those are 3 cores. Or Core i7, Intel Core i5, Intel Core i3. It means there are 3 cores there. And it is still expensive. A GPU can have up to 3,000 cores and still be cheaper than a CPU. A GPU clock speed might be slower. So you might get a CPU that is maybe 2 gigahertz speed, and you get a GPU that is 800 megahertz. But that 800 megahertz is to do only one thing. That 2000 megahertz is to do 50 things. So the GPU becomes much faster. Now, when you're choosing an AI provider, what you need to look for, you need to do a SWOT analysis and see, for what I intend to do, who is the strongest, who is the weakest, who will take me where I want to go, and then make that decision. Let's look at a real life application. We've talked about the cloud service, AI services being powered from the cloud. But what is an example of how AI is currently being used? Because as I've said, there's a lot of hype on the internet. If you search even on YouTube or anywhere, majority of the videos there are talking about a utopian kind of life that doesn't exist even right now. Yeah. You saw the video that we watched about IoT and insurance, where a drone came, took photos, the guy was sorted immediately. That is still in the near future. It's not something that is happening now. That was just an ad. But this video shows what is currently happening. And this is a store owned by Amazon. Amazon has gotten into the retail business to run supermarkets. And they are in the video, we'll be able to see how they are using artificial intelligence to do retail in a different way, not in the traditional way where the way supermarkets are run in Kenya, for example. Let's watch.
Welcome. Swipe in here. Amazon Go is the ultimate grab and go shopping experience.
You literally grab it off the shelves and go.
You use the app to enter the store. Once you're in, you can put the phone away. And you shop the rest of the store just like you would any other store, with one key difference. When you're done, you could just walk out.
It's simple for customers, but nothing is simple about the technology behind this cashierless store. The Amazon Go market uses artificial intelligence to monitor what you've reached for on the shelf and to make sure you're charged for what you walked out with, and nothing else.
What we had to do unique in this use case was build the sensors, the cameras.
All these cameras and sensors.
The cameras in the ceiling. We had to build the specific machine learning algorithms. The problem that we have to solve in Amazon Go is who took what. When I take this item off the shelf, it's in my virtual cart. When I put it back, the item goes back. It's an easy problem to solve when you have a single person in the store, but when there's multiple people, a lot of products, if you look around, look very similar to each other.
Right.
So that's where the challenge comes in.
The Amazon Go store is by no means the only place where Amazon uses AI.
We've got hundreds of teams working on artificial intelligence programs across Amazon. Artificial intelligence, like machine learning, powers the simplicity that we always want to offer to our customers.
Whether it's fulfilling orders or delivering packages.
Perfect.
Those teams are working constantly to improve the customer's experience.
We work from the customer backwards, and we create these simple solutions, map tracking of a package as the driver makes their way to your house, and then photo on delivery. They're super simple for customers, but behind the scenes, there's sophisticated artificial intelligence and machine learning that power it.
Inside Amazon's warehouses, AI is hard at work. These are Amazon Robotics drive units.
Once a customer actually purchases an item, either on their mobile app or on their computer or laptop, the system identifies the pod where the item is actually located in a field, and the bot maps out the most efficient way through using machine learning to get that pod, which has that item that that customer purchased, to the associate.
So there's some people out there that will hear robots, machine learning, AI, and think jobs, they're going to be gone.
What we've actually determined when we've actually deployed our solutions in our fulfillment networks is that we actually are relying a lot more on our associates. We've increased their efficiency, and it really gives them the ability to work on different tasks. And we've actually grown our associate employments across the globe to date.
Alexa, order dog biscuits.
And of course,
1 moment.
the AI tool you're most familiar with
Here's what I found.
is always learning new tricks.
So I'll give you an experience that you might want to have when you come home. You've had a long day. So you just come in and say, Alexa, good afternoon.
Good afternoon. Welcome to the Day 1 Home Lab.
Lifting the blinds.
She lifts the blinds.
88 degrees Fahrenheit with partly sunny skies. Tonight, you can look for clear skies with a low of...
The kettle is on.
Yeah, some music.
Now she's going to play music for you.
Really setting the scene.
Yes.
She's doing all the things that
Yeah.
like, oh, I'm too tired to do it.
She'll do everything except take off your shoes.
Okay.
Right?
That
So
I can
you
handle.
still have to
That
do
I can
that.
handle.
Yeah. Achieving what Alexa is right now is a super hard challenge. Going from that to the future, I would like Alexa to respond to your mood, your sentiment, your feelings as expressed in your speech. The one key advantage we have is we now have so much more data. So is it a big challenge? Yes. Are we up to that challenge? Heck yes.
The evolution of Alexa. Is it still in its infancy? Is it a toddler now, or is she a toddler now? An adolescent, teenager? Certainly hasn't graduated from college.
No, AI hasn't graduated from college overall, right? And I think AI as a field is in its infancy. Think of it as a older toddler, who's going to grow up to be an adult that just stuns us with her brilliance, right? Is where we are.
So that video actually showed us real-life application of AI. This is currently being in use in Amazon Go stores. And there are many questions that are not really questions, but concerns about how fast Amazon is growing. And that's something that I'd like us to discuss. It's specifically touching on Amazon. And more so from a regulatory perspective in terms of what is it that we can do to enable such organizations or leverage the rapid expansion of such organizations to achieve the SDGs. Because when I talk of regulation, I don't mean only when it comes to competition, like let us stop Amazon from being this giant competitor. I mean, this giant monopoly. That's not what I'm talking about. I'm talking about enabling the environment in which these players are playing to make it more efficient. We have use cases locally of companies that are utilizing AI and emerging technologies in the supply chain. There's an organization called Trigger Foods. Trigger Foods does fresh produce supply chain delivery. They can deliver maybe to your door. They can deliver to supermarkets. Where I live, majority of the mama mbogas there no longer go to Markiti early in the morning. All they do is simply wait, and Trigger Foods will deliver their produce there. And they're using technology, barcode scanners, RFID, IoT. And one of the things they are guaranteeing is quality and a fair price. So if mama mboga stopped going at 4 a.m. to go buy mboga in Markiti, at least where I live, that has virtually stopped. It's Twigafoods and other incoming players like Soccerwatch who are doing that. So how do we enable these players compete in the same space as Amazon, which has Amazon Go? In an Amazon Go shop, all you need is the Amazon app. As you get into the supermarket, you simply scan on the entry, the turnstile turns, and you go in, and shop. Whatever you remove from the shelf, it's immediately added to your cart, your online Amazon cart. And if you walk out with it, then that cart is automatically billed to your Amazon, to the billing details that you provided on Amazon. So it's a way in which you completely eliminate the store attendants, majority of them, not like everyone, and improves the efficiency of shopping. Because now when you go shop, you do not have to queue, you do not have to pay, and it's much faster. The convenience that people are seeing from that, you should read some reviews online about Amazon Go, and that is expanding. So the question is, how do we create an AI policy framework that will help us utilize AI to our advantage? Because the uses of AI might vary from country to country, depending on their level of development. In our case, we may be concerned about making sure that we bring the unconnected online. How do we use AI to do that? We can maybe use language. That is one use. That use might not be very high up in the list of priorities, maybe in the UK, as far as their AI policy is concerned. Now, when you talk of policy, it's basically what does the government want to achieve at a very high level. Then from the policy, we can then say, for us to do this, we must put in place the following laws. Then there's a law that is made. Maybe the Emerging Technologies Act of 2020 something, and then it is passed to become a law and signed into law. Then on that law, we can now come up with regulations to regulate whatever we want to regulate. And these regulations should actually work towards achieving the policy. So if the policy is to encourage innovation and growth of AI, then the regulation that is behind that should achieve that, not impede it. So according to me, the framework around AI policy should at least touch on ensuring that we utilize AI to accelerate development in the country and encourage innovation and growth of AI, yeah, because we've seen AI promises, if done well, can do a lot of things and significantly improve the way we live. And it will improve fairness, it will improve welfare and transparency. So the same way the government right now is focusing towards mobile development and innovation, IT innovations, there's also a need for the government to now start focusing on AI innovations. And AI innovations are not just technology innovations. There are so many aspects when it comes to AI innovation, because remember, when you're talking of AI, you're talking of systems that can interpret things like emotions, that can figure out things much faster than we can, and can create leverage in ways we thought not possible. So what are the innovative ways around that? When the mobile phones revolution started in Kenya, no one imagined buying power units from their phone. It was like, how? No one even thought about that at that time. No one imagined today the phone could be used to do nearly everything. You can read, you can watch movies for entertainment, you can listen to podcasts, you can make phone calls, you can chat. It's basically a mini computer. But in the year 2000, when mobile came, it was only about making phone calls. In fact, there was no SMS. SMS was being provided by a third party. And then now the provider started providing it. So we have slowly grown and embraced mobile. And that has been made possible, specifically in Kenya, because we had a very good policy framework, which resulted in very conducive regulations concerning how mobile technology will help us advance, and it has achieved that. So we can repeat, and this is the reason why even other African countries hold Kenya in very high regard, because we tried to do things right and we did them right. So in the same space, we need to do what we did in the mobile space in AI. As I've said, AI is not like a subset of a technology. AI is a means of production, yeah? And it provides leverages that other systems can't, and it needs to be handled carefully and different. It's a totally new way of doing things, let me put it that way. So we cannot, it's not business as usual. Now, the other thing that the policy should look at is stewardship of AI application, so that because of that, we need to ensure that the application of AI actually is accompanied by public trust in AI. We shouldn't have systems being implemented and the public trust is lost. Like there's a lot of talk of China monitoring their citizens, being a police state, and all that is because of AI. We can do it differently and reach a point where the public trust in AI is very high. One thing people need to realize is that it is only the Western world that is concerned about how China is applying AI. The citizens are okay. Chinese citizens, they're okay. Facial recognition, good. If it makes my life easier, why not? Social credit system, good. If it will eliminate bad elements of societal behavior, then why not? The Chinese citizens are okay with it. It's the Western world and the NGO types that are concerned about that. But the aim of a good policy framework is to ensure that there is public trust in AI, and other than just public trust, the public actually participate in enhancing the use of AI. And we are already doing that in Kenya in other areas. We have public participation, maybe like, for example, when the regulator wants to enforce infrastructure sharing, there was public participation where people gave views. I gave mine also, that was a while back. I gave my views. So I participated in making sure that whatever the country is trying to do is done right. So that is one element that should be focused on. Then the other element that the policy should focus on is the scientific integrity and quality of AI training. And by AI training here, I do not mean students in a college being trained in AI programming. I mean the AI itself being trained. How is it being trained? Are we replicating offline biases into AI? Yeah. You see, the same way we have laws or recommended, I don't know whether it's a law, but in organizations, you're not ideally supposed to profile staff based on tribe or discriminate against them based on that. So that is offline. How will we ensure that the same is adhered to in an AI-powered HR system, for example? So we need a framework to ensure that that happens. Then the other thing is the scientific integrity of this training. The methods I've mentioned there are to train good AI. The other methods like adversarial AI, adversarial machine learning, you can read about it. So how do we prevent somebody maybe from using adversarial machine learning on a certain type of AI outcome, which might not really be the outcome that is desired because we've used the wrong machine learning language, machine learning approach, I mean, yeah. So those are things that they need, we need to look at. Then the other thing is safety. We need to ensure that the policy framework addresses the issue of risks in use of AI and the security of use of AI. I gave you an example the other day. If somebody comes across my Fitbit data that shows that I do 10,000 steps a day, that data might not mean much. If they come again across another piece of information that says I do 10,000 steps a day,
You're quiet.
It disappeared.
Can't hear you, Tom.
can you hear me?
Yes, you're back,
Yes, now.
but you're disappearing.
Can hear you now.
Can you hear me?
Yes.
Yes.
Sorry, I don't know what happened there. Same thing happened as yesterday. So we had talked of the risk on the policy framework. Did you hear my discussion on the policy framework?
Yes.
Up to where? Stewardship. Stewardship
you finished.
The next slide.
In the next slide. Okay. So when it comes to risk, let me do the slide. The policy should also be able to address risks that come with the application of AI. And it should also be able to address security concerns of AI. And I gave an example where we yesterday, but one where I said, if somebody, for example, comes across my data from an IoT device, let's say my Fitbit, my exercise Fitbit device, and they come across data that I do 10,000 steps every day. That data might not mean much. Yeah. But if you had another second piece of data that says these 10,000 steps are taken between, let's say, 4 p.m. and 5 p.m., then that data becomes richer. And if you add another piece of information that shows these 10,000 steps, not only are they taken between 4 and 5 p.m., this is the geographical location of where these steps are taken. So with those three pieces of data, if each data was presented to you independently, you would not make much of it. But with the three pieces of data presented to you, you will be able to even stand by the road that I jog every evening and pinpoint me and say, that is most likely Thomas, based on the information I have. I do not know him, but that is most likely him. Of course, you might do that for 2 days. The day one, you see somebody, you know, I've seen 4 people today. Day two, you discover I've seen the same person I saw yesterday passing here jogging. So this must be Thomas. So that is how easy it is to breach the security or the privacy of people who use AI or systems that employ AI. So the policy should cover things to do with safety and security of AI use and the risks that arise from that. Yeah. The other thing which the policy should focus on is the government should ensure that barriers to entry for AI use, either in terms of the technology or the knowledge or the tools or any other form of barrier that might exist for proper AI adoption, are lowered or removed. And maybe one way of lowering barriers to entry would be the government might decide would want to incorporate all the 42, there are now 43, I think, 43 national languages, 43 tribes and their dialects into our AI strategy as a government. That's one way in which we are going to ensure that that person in the village who does not speak English or neither can they use a mobile device effectively, how will they benefit from AI? They will not benefit from it, and they might be left as the world progresses because their language hasn't been incorporated into conversational intelligence. And you'll see next week on Monday, we'll cover AI specifically on the area of language processing, because that is one area that will dramatically change how we work and live. So lowering barriers to entry is very important. Then the policy should also be able to address our specific needs. We are unique as a country. What is working in America, or what is high priority in maybe the UK AI strategy might not be what is priority to us. Maybe we need to utilize AI to solve our most pressing issues, health, education, and so on and so forth, maybe. Yeah. In other countries, their priorities might be different. So we need to have a policy framework that will address specific needs. Yeah. And by doing that, we'll have greatly enhanced or fostered our country's position to become a power. The same way when in Africa you talk about ICT, technology development, Kenya really comes into mind in many people's minds when you talk about tech. The most popular one, of course, is M-Pesa and financial inclusion. We are popular in that because we had a conducive environment and a conducive policy framework that actually encouraged that to happen. Yeah. And that is what we need to do. The policy framework should be geared toward that. I've repeated the last point. Yeah. But addressing the issue of risk I've mentioned, and that is what I believe would really work towards taking the country forward as far as AI is concerned. Sijui kama kuna swali mpaka hapo. So this is a short video that will show us how AI is being used to meet the various SDGs. Yeah, so just watch. of the biggest texts out of that video is that AI is not just a technology, it's an approach to doing things differently, yeah? And it being an approach of doing various things, it will be wrong to call artificial intelligence a technology, because it needs multi-sectoral approach. When you're talking about AI, you'll be involving more bodies and more people than you would in technology. If, for example, you are regulating a RF spectrum, you only need technologies to tell you what to do and you'll meet your objectives. When it comes to regulating AI, you need psychiatrists, psychologists, you need people who study human behavior, you need people who understand our moral inclination, because what might be morally okay in other countries might not be morally okay here. So these are the things that, that it has to be a multi-sectoral approach. And the application to solve these problems is actually something that can really accelerate the way we do things. You saw in the first example how satellite imagery data can be used to maybe conduct population studies and so on and so forth. Recently, Zambia did census of housing, rural housing, using satellite and AI. So they're able to know in the country we have these square meters of floor space as rural housing. This is the average floor space in a rural house. This is the smallest, this is the largest, this is the average, this is the distribution. So that data could not be gathered by use of people walking around, sensors, like tumekuja kupima nyumba. It wouldn't have worked. But by use of AI, such data can be inferred from images, just satellite imagery. So the satellite simply took the image, a very high quality image. And for information, what we see on Google is actually very low resolution image of what that satellite is capable of. That satellite can read a headline on a newspaper on Earth if you hold it out in the sky. The reason why Google is blurred is maybe because of security. And then also if you want clearer images, you pay, yeah? So satellite imagery is being used in new ways thanks to AI. Satellite imagery used to exist before AI, yeah? It's been there since the Cold War. But now with the use of AI, we are able now to achieve some of the developmental objectives that we desire, because AI can quickly and easily provide us data to base our decisions on, yeah? The data is also being used in many other ways, as you've seen in the video. And the video has shown how each of the 17 SDGs is utilizing AI and advanced technologies to accelerate its achievement. There's another video, maybe we can watch this one, AI for Good by the X Prize. So let's note that my internet is a bit slow today. Tell me if you see the video. This is not my internet, very slow. Something wrong? Let me see. disappointing us. So, but you can look for this video. It's called AI for Good, SDGs and Moonshots. It's a very good video that highlights how the SDGs can be used. I mean, how AI can be used to quickly assess. Oh, here it is.
We face extraordinary challenges in the 21st century. 9.5 billion people alive in 2050. We don't know how we will provide them clean water, sustainable energy, education.
There are serious problems with the environment. There are serious problems with bigotry. There are serious problems with poverty and starvation. And so far, we've been unsuccessful in figuring out a way to fix them. I'm hoping that AI can adjust the various factors in a way that maybe can solve these problems.
The real opportunity for AI is how we can actually help the 7 billion people that could benefit from these technologies in a practical way.
While we can't say AI is general magic, it is giving us core tools to start putting in place systems that we know will help with key issues like hunger, famine, epidemics, overall health and well-being.
AI offers an extraordinary possibility of accelerating solutions in the time we have to solve the problems.
We are now applying artificial intelligence to the art of farming, a very old industry, also adopting the latest in technology. So through artificial intelligence, a farmer can now integrate massive sources of data, whether it's data from the combines, it's weather satellite data, it's data from the fields, taking all that data together and through an artificial intelligence solution, actually making recommendations to the farmer on how he can increase the production of his land.
AI has enormous capacity and potential to solve problems that require an enormous amount of computing and pattern recognition that human beings struggle with.
The way drugs are going to be designed in the future, and again already starting to be, is by having models of the molecules and how they interact, for example, with, say, the virus proteins, and then doing a search to find the best drug for the best problem. I think this is, for example, how we're going to cure cancer.
By 2020, you should be able to walk into your doctor's office. Your doctor should be able to sequence your entire genome, take that along with your medical imaging data, compare that with the world's data of genome sequences and medical imaging data. From that, determine the matches between your tumor and others, what the treatments were in those other cases, and the outcome. Did the patient survive or not? And from that, devise for you your personalized treatment and do that entire process in just one day. It's completely possible through artificial intelligence.
The UN summit and its goals excite me, in particular with the idea of leveraging what I would call sleeping giants of data. We have accumulated so much data in the world, and with some refinement and some tagging, this data can become available and leveraged to address famine, to address human trafficking, to address vicious cycles of economic poverty.
If you make progress in AI, you make progress in all these different fields at the same time. Right? So better machine learning algorithm, if I invent it tomorrow, it'll make for better medical diagnosis, it'll make for better self-driving cars, and who knows what else.
AI is potentially the most powerful technology that we've ever created, and it's going to create the next form of civilization. It's not happening in 10 years or 15 years, it's happening right now.
So that video was shot in 2017, and in one of the speakers there said by 2020 you'll be able to fully sequence the genome of the disease that you have. And this video was spot on, because when COVID was announced the other day, the Chinese scientists were able to sequence the genome of COVID very fast, something that was impossible. And what they did is that they were able to sequence the genome of the COVID virus and avail it online for any researcher who wants to use it. And that is why the world is very confident, saying that we are going to get a COVID vaccine in the next 18 months. It's because we are very certain that this is something that is working, and we only need to be a little bit patient as we run the models through the paces to ensure that we get the correct drug. But as it's been said, within 18 months or even less, we'll get a vaccine. This has never happened before. We've only been getting vaccines maybe after 8 years or 5 years of research. Some even take much longer. But within 18 months is truly significant. So I'd like to stop there and maybe invite questions from everyone in as far as the session is concerned, or any other previous sessions that we did and you'd like to seek clarification on. Today there has not been a single question. Does that mean we've understood, or whatever I'm talking is difficult? Or it would be good to get some feedback to know that we have achieved the objectives of the session or not, that we see what areas we can address.
I think I'm good.
You're good, eh? Thank you, Haji. Anyone else? So thank you very much to everyone who has joined the class today. The aim of this first session was basically to introduce artificial intelligence, what it is and what it's not, and mention that there's a lot of hype around on artificial intelligence and what it can do. People think it's a magic wand. It could be, but in as far as realistic expectations are concerned to solve the current problems we have, we are not as far as the hype portends, but we are accelerating towards that area. And as time goes on, we'll see the advancement of AI, which is actually accelerating exponentially. In the next session, which will be on Monday, we will still cover AI, but now from a practical use case. We'll be predominantly looking at conversational AI. And conversational AI is one of the most mature narrow AI sectors today, to the point that it is expected to revolutionize how we interact with computers. And I mentioned, and I gave it should be possible for somebody who is not an English speaker from Kenya, who can speak mother tongue. It should be possible for that person to browse the internet, buy things online, set reminders on their phone, carry out M-Pesa transactions or any other transaction that they wish to carry out on their phone, get info about maybe the weather or anything that they fancy, all through speaking to their phone. Not really their phone, but a digital AI assistant in the phone. So when you speak to the phone, like when I spoke to Google the other time, Google Assistant, and I say, hey, Google, that is the Google digital assistant, which is powered by AI. So when I talk to it and say, hey, Google, I'm angry. So when I tell Google I'm angry, it needs to interpret what my intention is. My intention could be anything. For example, if it's nearly lunchtime and I say I'm angry, then my intention is to eat. If, for example, I say, hey, Google, how is the traffic to Westlands, like the example which we saw? It takes my intention as going to Westlands. So it will tell me about the traffic conditions and how long it will take me to get there. So there's a lot behind that response that is AI driven. And these are things that we need to cover next week. It will be slightly technical, but not to the point where we won't be able to follow. But the aim is to show you the technical components that exist that power AI. For example, we will be going to the Amazon or the Azure, Microsoft Azure platform, the portals, and see if today you as an organization want to train a machine learning model, maybe that would predict telecom network system failures. Where do you start? Because that is still abstract to many. Where do I log in? What do I click when I log in? What is this that I'm clicking and what does it do? Where is all this data from my IoT devices going? Where does it sit? How is it processed? That's what we need to look at. And it'll be very exciting, I promise you, because it will go into the belly of what really powers artificial intelligence.
Hello.
So I beg to stop there, and I thank you all. Sorry?
Oh,
Oh, sorry, that's somebody on phone. Eh? So I think we can stop there, and unless there's any questions, thank you very much.
Hey.
Yeah, nice weekend.
You too, enjoy, and bye.